My name is Akash Hamirwasia, and I'll be sharing some of the learnings I had while adopting the latest and greatest React compiler in my own product. My name is Akash Hamirwasia. I work as an engineer at 11 Labs. How many of you have heard about 11 Labs? We are building the best AI audio platform out there. So things like text to speech, voice cloning, voice changer, everything is something that we are building right now. You can follow me on Twitter. I also have a website. You can check it out. Now, in my free time, I also work on this product called Slanted. Slanted is a tool to create really catchy looking 3D product videos, which you would find in launch keynotes of various big companies. They might show their softwares in a very fancy way. And Slanted allows you to create it with just a few clicks. It's a simple web-based tool. Now you can see this is a fully fledged editor on the browser. You can drag in clips, you can resize things, you can make edits to your videos on this tool. You can check it out at slanted.app. But the reason I bring this up is because UI heavy and creativity applications like Slanted need to be extremely performant for a great user experience. Think about tools like Figma. What if Figma lagged when you drag a node or resize something? It would be a very poor experience, right? So it's very important for these applications to have extremely high performance. And while React makes it easy to build complex interfaces declaratively, we must have to think about UI performance at some point. We just can't ignore it. How many of you are familiar with this? Okay, few. I think most of you haven't tried this out. It's a nightmare for developers, but do give it a try. So this is a standard React profiler flame graph showing how many re-renders happened for a particular interaction. And you can see it's not that great. An entire tree got re-rendered and all the nested components are re-rendering multiple times. Now in this particular graph, one thing to highlight is this small component here called clip, short clip. These are individual clips that you add on the timeline and they render on every time change in the timeline. So whenever you seek around, every timeline clip component re-renders continuously, which is insane. Now we can fix these things using some hooks and APIs that React already provides. Things like react.memo allow you to wrap your components so that it only re-renders when the props passed to it change. There is a hook called useMemo that you can use to wrap expensive parts of your component and make sure that they only run when the dependencies of those code change. Now, some of you might not be aware that you can also wrap JSX inside useMemo. So in this example, inside this clip component, I have a drop-down menu that I show, and it re-renders very often. It's quite expensive. So I've wrapped it in a useMemo. It returns the JSX, and I simply render it while returning from the component. And finally, there's also useCallback, which is similar to useMemo, but it works for functions. Applying all of these APIs, this is what I was able to get. So it has optimized the entire clip component, and none of those clip components are re-rendering with every change in the time on the timeline. Now, this looks nice, but it's very cumbersome and very hard. It took me days and weeks to figure out what is exactly changing and make sure optimizations are working correctly. Now, to combat this, in 2024, React team launched React Compiler in beta. And what this does is it applies automatic memoization in your React code base through static code analysis. Now, this is being used in production at Meta. So it's no longer an experiment or a tool, it's already in production. And soon we will also be adopting it in our own projects. Today, in 2025, React Compiler is in RC, which means most of the work is already done. The next step is to make it stable. So now is a good time to give it a try if you haven't and see how it works with your code bases. Now the compiler's goal is to ensure only relevant parts of your app re-render as the state changes. This is also known as fine-grained reactivity. When certain state changes, only the code that is dependent on that state should re-render, nothing else. And React Compiler does this all by performing static analysis of the code based on the rules of React. Let's take a look at what these rules of React are. You can check it out in the documentation. I'll just go. So it says component at hooks must be pure. And there are multiple different rules within this rule. The second one is React calls components and hooks. So you shouldn't call them directly as functions. Hook should be called inside React components, and components should be used as JSX, not direct function calls. And finally, the rules of hooks that we are all familiar with. You should call hooks at the top level, not inside loops or conditionals. And you can call hooks only from React functions, which can be other components or hooks in the code base. Now, if any of these rules are broken, the compiler skips that particular component or the hook. So even if another hook is following these rules, that will get optimized, but the particular hook or component that fails these rules will get skipped. Now let's look at the kind of optimizations or memoization this React compiler adds to our code. So this is a small component from Slanted. It renders two input sliders, and let's see what happens when I pass this through the compiler. Very hard to read, very garbled code, but what you can understand is it does dependency analysis of different parts of your UI, of your logic, and it caches everything and only makes sure that the parts of the code run when those dependencies change. For people who think this is AI, I'm sorry, it's not. It's called static analysis. It's a very powerful technique that has been used since the dawn of programming languages. It just transforms your code and generates new code. It's not AI, OpenAI, Gen AI, sentient AI, whatever. So how do we get started with React compiler? You need to have React version 19. How many of you are using React version 19 in your production code bases today? Okay, there's like 3, 4. Okay, React 18. Wow, React 17. Okay, so people looking to switch jobs, make sure you don't join these companies. But yeah, if you are using React 18 or 17, or let's not go older, React 18 or 17, you can still opt into using compiler using the React compiler runtime package. The compiler depends on certain runtime APIs that are available in React version 19, but you can use this to get started as well. Docs has instructions to get started with Next.js. It works with React Native as well. So it's not something that's only for web, and you can follow the docs over there. There are two packages that you should be aware of. The Babel plugin React compiler, this is the compiler itself, and the ESLint plugin, which surfaces the errors that the compiler shows, which you can fix based on the rules of hooks, and the compiler will then optimize. My suggestion would be to start with the ESLint plugin today to prepare your code base for the React compiler in the future, and make sure to remember it's not necessary to optimize 100% of your app on the day one. It's fine if you start small. There are instructions to run compiler only in certain parts of your code base, and slowly you can expand it to the entire application. Let's take a look at the compiler output. So you can identify the optimizations that are being made by the compiler using the memo blue badge in the React DevTools. And it has already optimized quite a few components in my Slanted product. So inside Slanted, it memoized 218 components out of the 237 components or so I have. It's about 92% of the code base. And you have to note that I already did apply some optimizations. I adopted React compiler. This was manual memoization in timeline because I noticed there were performance issues in that. And also something called micro global stores. I'll leave that as a suspense that you can await on after the talk. I instantly started seeing less re-renders in the unoptimized parts of the app. So when I'm changing the timeline, you can see very few things are re-rendering now. In fact, I think this is the unoptimized version. So it re-renders quite a lot of things inside the video player itself. But if I show you the optimized version, it actually doesn't render one particular track, and only inside the video player it renders just the slider which is changing. So optimizations already show some improvements. Now, unfortunately, React compiler is not a silver bullet. A silver bullet means something that just works instantly in a magical way. But it's not a silver bullet yet. And I know that the compiler team is working very hard so that you don't have to think about the edge cases or the caveats it has, and you can simply adopt it directly. Now, the caveats that I encountered were, I realized certain parts of the application simply lost reactivity altogether. So to understand this is how I represent timeline in Slanted. It's a complex object, and there is a field inside this timeline called duration. It's a computed property. It calculates the duration based on all the tracks the timeline has. And there are multiple such computed properties all living inside this timeline. Now, my mistake was using this directly inside the render function, inside a component, to render the duration of the timeline directly. And while this did work, it was working because the video player component was re-rendering multiple times as the timeline was changing. So it appeared to work, but with the excessive re-renders removed, this component didn't render when the duration changed. And the compiler didn't complain. It thought it was semantically correct, which it is, because it just treated this as a global variable and it realized it doesn't change, so we don't need to optimize for it. So here's the problem in action. Notice how the red circle, that's the duration of this video. I'm adding more clips, changing things around. It's not updating. When I try to resize or move the timeline, there is infinity nan, all those nasty things in the timeline. So I fixed this by using Vault.io. It's a package for adding proxy-based reactivity in your applications. This is a complex project, so it uses mutation-based updates at some parts. So I need to use something like this so that the state updates are targeted to certain parts of the store. And now the component only re-renders when the duration value changes. So if you encounter this particular problem when using the compiler, remember it's not the fault of the compiler. It's typically due to buggy code that appeared to work when there were excessive rendering. It can be caught with tests, but let's be honest, how many of us have tests? You can convert the unreactive parts of your state to reactive state if required to solve this issue. The second one is incorrect manual memorizations. So whenever the React compiler encounters certain components that are using use memo hooks, but the dependency array is incorrect, it simply ignores that hook or component. So let's take a look at an example. This is a hook that handles number inputs inside slanted, and this particular function is a use callback hook. And if you notice a problem in this, well, this particular line where I'm passing the dependencies array, it doesn't have all the dependencies defined correctly that this function needs. There is a variable called min, max, step, all of these aren't included. So the compiler simply skips this and it decides it's not worth optimizing. So when you encounter such cases, it can have some cascading effect on other components that you have in your code base, and make sure the dependency array that you have in your custom use memo use callback calls are correct. Compiler tells you what's missing, so it's very useful. It'll just point out that, hey, you have forgotten to add this thing which is changing, so you can just add it. And it can happen quite often, especially in large teams. Some developer changes something, they forget to update the dependency array, and your code is broken. You can fix the dependency array manually, or even better, just remove the use memo or use callback, because the compiler can handle it in a better way than you. Now, how do you find such compilation issues? As I mentioned, use the ESLint plugin that is already out, or you can also use the React Compiler Playground. It's a simple web-based tool where you can just paste the code. It doesn't require npm install or anything. Just paste the code, it will show you the output. You can understand how the compiler works and see the output and the errors that it shows. The third caveat was the external libraries that you use will not be optimized automatically unless the library itself uses the compiler during its build process. So this is another snapshot from the profiler. Notice how a lot of these accordion-based components are still re-rendering. They are not optimized by the compiler. These components are coming from a package that I use called ArcUI. It's similar to Radix UI or Chakra UI. And do note that these components, at least internally, won't be optimized by the compiler. The library author must adopt React compiler, and once it's built in their build pipeline, then you can adopt this updated library, and then you will see the optimizations. Not very ideal, but we can't really do much. I've also encountered sometimes the compiler's optimization isn't really ideal. And let's take a look at this with an example. So this is the same depth of field component that I have with two sliders. And now I'm rendering this whenever the enabled flag is true. Very typical React code that we write day to day. This is the output from the compiler. Now, I don't know if you notice, this particular part, which is wrapped inside the conditional, is actually not the best way to optimize this component. The settings number for blur strength and focal radius both depend on blur and focal radius, which doesn't make sense. When blur changes, only the first slider should change or re-render. But in this case, the way it has been optimized, both will re-render when either of them changes. Now to fix this, in fact, let's see what the problem is. So when I change the focal radius, even the blur strength slider is re-rendering, which is not ideal because that hasn't changed at all. So to fix this, we can do some rewrite in the code. What I tried was, wow, okay. So what I tried was actually changing the ternary to be an iffy and then return with the if condition. And surprisingly, this works. The compiler now optimizes each slider individually, which is correct. But honestly, the code that I've written is not ideal. I don't want to see these kind of things in code reviews, right? The other way to fix this is extracting the conditional parts outside in a separate component, passing the dependencies as props, and then the compiler also picks it up. I have a feeling this will come into the compiler inherently, so we don't have to think about it. Extracting components is already supported. I think it's behind a flag, but I couldn't find it. But this is something that you might have to keep an eye out. Finally, the last part, measuring the impact of the compiler. You can use React Profiler or React Scan to see which components rendered and why. I've already showed the output of React Scan. It shows nice highlightings live when the component re-renders. You can also check for why a component re-renders simply by inspecting the component. So it's much better than React Profiler, which requires you to record and then trace the output. Here you can just select a component, change the UI, and you will instantly see why that component re-rendered. You can check it out at reactscan.com. And this is what my flame graph now looks like. So this was before with all the short clips, all the clips in the timeline rendering. Now it has been reduced to this. So the video player is very optimized. The clips itself are optimized, but it is using a lot of third-party components as well, which is still re-rendering because they are not internally optimized. How does this affect real users? We have seen a lot of graphs, right? Well, I've noticed it negligibly increases the bundle size, so it's fine to use it. Similar FCP, LCP scores, all the components still have to render in the initial mount, so it's not really going to change that. It can slightly increase your parse time. It's hard to measure this, but this is my hunch because the code generated is very large. It has a lot of JavaScript conditionals, so maybe the parse time might be higher. But the most important thing to measure is the interaction to next paint. You can measure this using Performance tab or Lighthouse during development, or with tools like Sentry or PostHub, which will track INP across all your users and plot it in a nice graph. This is what I see for slanted. So this is before the optimization. Whenever I change the progress bar, you can see there is around 40 milliseconds, 44 milliseconds on average worth of time it takes to render the next frame. Now with the optimization, this reduces to around 24 milliseconds. So it is 44% reduced. And this is with the optimizations that I already applied. So do note that because this is a very performance intensive application, a lot of parts were already optimized. So in your case, you might see much bigger gains with something that's not very well optimized manually. With more changes, I was able to get the coverage to 94%, but do remember that you don't have to aim for 100%. It's fine if certain parts of your app do not get optimized. I still have some issues with refs. There is a rule in React. Gosh, there's so many rules, right? There is a rule which says you shouldn't use refs while rendering, but I need to because I know I'm smart and I'm applying my own optimization, so I ignore that compiler warning on my own. And finally, it's a great feeling to see that now lesser components are re-rendering and I can go back to writing buggy code that degrades performance again. With that, I have reached the end of this talk. Thank you for listening. You can check out Slanted, Twitter, website. This is not a UPI QR code. It's a website QR code, so you can scan and check it out.